Hey, is this thing on? Oh, we're rolling? Oh, okay, we're rolling. You're going to cut that at the. Okay, good. Hey, scale factor with 2D drawings, two-dimensional drawings, meaning flat shapes on paper. Okay, today a very short talk about that. So, scale factor. Look at my little example here. This demonstrates what scale factor is. Scale factor is just a ratio that is written as a fraction. What is scale factor? Ratio written as a fraction where the copy is on the top and the original is on the bottom. Now, rhyming is a great way to remember stuff like this, and here's what I've taught in class, and wow, just everybody remembers this. It's so brilliant. Check this out. Copy on the toppy. Copy on the toppy. It rhymes. Original, I don't know what that rhymes with, but it doesn't matter. It goes on the bottom. Original on the bottom. The key, though, is copy on the toppy, and then whatever's left on the bottom. Okay, so when we're using scale factor, we can either make things bigger or smaller. Although in the math books, they use technical talk like enlargement for bigger and reduction for smaller. So those are the big fancy words that mean bigger or smaller. You might need to translate those if you're reading some kind of problem in your math book, wherever you are. Okay, so let's do a little sample here. Let's say you have a problem that looks like this. We've got a rectangle. It's 6 units wide, 3 units tall. And it says make a 1/3 scale drawing. Okay, so when you see the word scale, drawing, stuff like this going on, the fraction is more than a fraction. That's your scale factor. And the 1 means something and the 3 means something. In this case, the 1 is the copy, because that's on the toppy, and the 3 is the original. So we can look at this and go, hey, is the copy going to be bigger or smaller than what we started with? It's smaller, right? Because 1 is less than 3. So we know we're going to be making a tiny picture. And to make it 1/3, all we do is this. You take the scale factor, multiply it by a dimension of the original, and you will get the dimension of the copy. Okay, here's what I mean. If I take 3, multiply the scale factor by 3, literally I'm going 1/3 of 3. That's 1, right? So I'm going to make the same side on my copy. It's going to look like that. And I'm going to label it with a 1. Then I'm going to take the 6. What's 1/3 of 6? 2. So the matching side on my copy will be 2. And there's my copy of the rectangle. Here was the original. That's how it works. Scale factor times any dimension of the original makes the dimension of the corresponding side of the copy. Okay? One vocab word to talk about here very quickly, corresponding. You heard me use that. Corresponding just kind of means matching. The matching side. Now sometimes, to find the matching side, you need to rotate things around. Like if I have a couple boxes of pens here, and they're like oriented like this, it might be hard to see the matching side at first. But if I say, hey, I want to match this barcode side, I might have to rotate, flip, and there's the matching side. So sometimes matching is easy to see because the shapes are lined up perfectly. Other times you might have to spin them or rotate them or flip them or do some kind of translation. Okay, so let's take the same shape that I just had and see how this works in other situations. Same shape, 6 by 3, and let's say you're supposed to make a 2-to-1 drawing. Okay, the copy will be bigger because the copy's on the Toppy. 2 is bigger than 1. So I'm going to take the scale factor times a dimension of the original is going to give me the corresponding dimension of the copy. So I'm going to take my 3 times the scale factor. I get 6, right? Easy enough. Then I'm going to take my 6 times the scale factor. Gives me 12. 3, 6, 9, 12. And there's my copy. There's my original. Okay, so in this case, the copy was bigger than the original. That's how it works. So your scale factor should always be written as a fraction. You should always have both numbers there, even when there's just a 1 on the bottom. That 1 represents the dimensions on the original. So don't wipe it out. Leave it there. All right. Another type of thing that might happen to you is you might be given 2 shapes and asked to find, well, what is the scale factor? Okay, this is a different type of problem, and it works very much the same way. Scale factor is copy on the Toppy, right? By the way, you can spell Toppy however you want to. I like to spell it that way. So we can take any 2 sides of the original, any 2 corresponding sides. So for example, the 12 corresponds with, right, the 3. The 3 is from the copy, that goes on top. The 12 is from the original, that goes on the bottom. Simplify it, and you get 1/4. Let's take another pair of corresponding sides. I'm going to take the 8 and the 2. So this is if you're working as a team or doing something in your classroom or just working with a friend. You could pick different pairs of corresponding sides or matching sides. You should still get the same answer. 2 is from my copy. This is the trickiest part, is make sure you always put the copy on top. Sometimes it's bigger, sometimes it's smaller. Just always identify the copy. Okay? 2/8 simplifies to 1/4. Look, we have the same answer. We could find another pair of corresponding sides here. We got the 16 and the 4. Which one is the copy? Right, the 4. 16 is the corresponding side of the original. We're going to simplify by dividing both by 4, of course, and we get 1/4. And notice we get this same fraction over and over again. That is the scale factor. The scale factor is just the simplified ratio comparing the corresponding sides, any pair of corresponding sides, from similar shapes with the copy on the top. That's it. Hey, thanks for watching. Stay tuned for more exciting scale factor videos to be made soon. Bye.